Uh-huh.
Are we doing synthetic division?
Yes.
Oh yeah, no, I love synthetic division. Long division should not be a part of that.
All right.
Shut up.
So today
Okay, let's get started, folks. Thank you.
we're going to talk about, really for a good part of history, what we're talking about today is what algebra was. Algebra was about solving equations, finding zeros. That's arguably why algebra was invented. How do we solve equations? So we want to talk about today, talking about solving equations with polynomials. Well, to do that, we need to talk about division first. So let's remember how we do long division. So we're going to divide 7213 by 61. So let's remember how we do long division. I ask myself, well, how many times does 61 go into 72? One time. So I put it up there, and then I multiply. 1 times 61 is 61, and then we subtract. 2 minus 1 is 1, 7 minus 6 is 1, and then we bring this 1 down. All right, now we ask ourselves, how many times does 61 go into 111? 1, because 2 times 61 is going to be more than 120. So 1, 61, then we subtract. 1 minus 1 is 0. I have to borrow here. So I turn this into a I got to borrow, right? So that turns into a 0. That turns into 11. 11 minus 6 is 5. Divide by, or bring the 3 down. Folks, let's stop talking, please. Bring the 3 down. Now I ask myself, how many times does 60 go into 503? So 6 times 8, that's going to be 480 something. 6 times 9 would be too big, right? I'm going to say 8. Multiply, 488. Subtract, borrow, that turns into a 49. So that's 13. 13 minus 8 is 5. 9 minus 8 is 1, and that's a 0. And then we say, well, 61 doesn't go into 15. So what this tells us is that 7213 divided by 61 is 118 plus 15 61st. We take the remainder over the divisor. We can also write this, or another way we can write this is going to be more useful for us. If I multiply both sides of this equation by 61, I get 7213 equals 118 times 61 plus 15. These two things mean the same thing. So what happens if I divide two numbers and my remainder is 0? What does that tell us? It's a multiple. That means that the number that we're dividing by goes into the other number evenly. Well, that's important. That's one of the reasons we use division, is to decide if a number divides another number evenly. Well, that's exactly what we're going to do with polynomials. All right, so let's apply this process that we just did to polynomials. So let's say we want to divide 2x to the third minus 5x squared plus x minus 8. And we're going to divide that by x minus 3. All right, folks, Enough with the chatter. Let's stop, please. So we're going to do the same process that we just did with these numbers, with this polynomial. And actually, I think it's a little easier with polynomials than it is with numbers. All right, so there's our division. To do our division, I say, well, what do I have to multiply x by to get 2x to the third? 2x squared, right? To multiply x by 2x squared to get 2x cubed. Now I'm going to multiply 2x squared times x minus 3. I get 2x cubed. 2x squared times negative 3 is negative 6x squared. And I'm going to subtract. I like to write the parentheses and put the negative sign there to remember to subtract everything. 2x to the third minus 2x to the third, 0. That's the point of doing this. I want that to go away. And 5x squared minus negative 6x squared. So negative 5x squared plus 6x squared. X squared. And I'm going to bring that x down. Now I say, what do I multiply x by to get x squared? So I put an x up there. Now I do the multiplication. X squared minus 3x. Subtract. X squared minus x squared, those go away. And I get x minus negative 3x. 4x. Bring down the negative 8. And then I say, what do I multiply x by to get 4x? 4. And this gives me 4x minus 12. Subtract. Those go away. And I get negative 8 plus 12 is 4. So this tells us that 2x to the third minus 5x squared plus x minus 8 divided by x minus 3 equals 2x squared plus x plus 4 plus 4 over x minus 3. Or, if I multiply both sides of this equation by x minus 3, 2x to the third minus 5x squared plus x minus 8 equals 2x squared plus x plus 4 times x minus 3 plus 4. And if we do this process, similar to what we talked about with the numbers, and our remainder happens to be 0, what have we done?
We found a 0.
Well, we found a 0, and haven't we factored this? If that remainder is 0? So division is how we're going to find zeros and how we're going to factor higher degree polynomials. Yes?
If we do have remainder, that's like we can't factor it? Or like that it's just like not factored?
Right, so then it means it doesn't factor. All right, so what I'm going to do is write out formally what we're talking about here, and then we are going to apply that to polynomials, and then we'll talk about a shortcut that we can use sometimes. All right, so what we're doing here is called the division algorithm. And what we're doing today is there's some argument that kids should not learn to do long division anymore because we have calculators. You need to do long division to be able to divide polynomials. So we need to know the division algorithm. So I would argue that the division algorithm is important. All right, our division algorithm says that for polynomials, f of x and d of x, where the degree of d of x is less than or equal to the degree of f of x. So essentially we're dividing bigger polynomials by smaller polynomials. Just like when we divide numbers, we usually want to divide a bigger number by a smaller number. And we're not we don't want d of x to be 0. We're not dividing by 0. We can find polynomials q of x and r of x so that, and we could add these polynomials are unique. There's not a different way to do it. There's exactly one way to do it. So that when we divide f of x by d of x, we get some polynomial plus our remainder over the thing we divided by. So this is exactly what we wrote back here. This thing. The division algorithm tells us for any polynomial, we're guaranteed that we can do that. The other way that we're going to write this, or I could multiply both sides of this equation by d of x. F of x equals q of x times d of x plus r of x. And we write r of x because our remainder won't always just be a number. Sometimes our remainder will be another polynomial. Some terminology. F of x is the dividend. D of x is the divisor. Q of x is the quotient. And r of x is the remainder. And just, yes. One more time, I just couldn't quite hear you. Then you can't do the division. Because there's not such thing as, so if when we do it with numbers and we get decimals, there's not such thing as decimal polynomials, very loosely speaking. All right, so let's look at another example, and then we will talk about a shortcut. We will get into synthetic division in just a second. All right. So we want to do this division, divided by x minus 2. 3x cubed minus x squared plus 5x over x minus 2. So I'm going to set up my division. Now, I'll save that for just a second. All right, so let's do our division. What do we have to multiply x by to get 3x squared, or 3x cubed? 3x squared. So I get 3x cubed minus 6x squared. I'm going to subtract. That gives me 0. Minus x squared plus 6x squared. 5x squared. I bring that 5x down. What do I multiply x by to get 5x squared? Plus 5x. Multiply. Get 5x squared minus 10x. Subtract. These go away. I get 5x squared minus negative 10. Wait, is this 5? Is this what I did? Yeah, okay. So that's going to be 15x minus 3. And what do I multiply x by to get 15x? 15 plus 15. 15x minus 30. I subtract, and negative 3 plus 30 is 27. So this tells me that this equals 3x squared plus 5x plus 15 plus 27 over x minus 2. Or this equals 3x squared plus 5x plus 5 times x minus 2 plus 27. Well, when we're doing our division by something like x minus 2, there's a shortcut. The shortcut is synthetic division. The thing about synthetic division works only for division by something like x minus c, where c is a number. If we're doing any other kind of division problem, if we're dividing by x squared minus x minus 5, if we're dividing by 2x minus 6, we cannot use synthetic division. Synthetic division only works when there's no number in front of the x, first power on the x, and a number after the x. That's the only time you can use synthetic division. So that's not that often, really. So we will need to know how to do long division. So what we're going to do with synthetic division turns a process into multiplication and addition only. So, for example, if we had 3x to the third minus x squared plus 2x minus 3, and we're dividing by x minus 2. Since we have something that looks like this, we can do the synthetic division. So what we're going to do is just take the coefficients in front of my variables. So 3, negative 1, 2, negative 3. I usually write the division, write it upside down. And we're going to take this number, x minus whatever, and put that number there. I'm going to bring the 3 down, multiply, add. Multiply, add. Multiply, add. 2 times 3 is 6. Add those. 2 times 5 is 10. Add those. 2 times 12 is 24. Add those. Yeah. Yes. And the fact that those signs are opposite is what allows us to add instead of subtract. This is our remainder. Yeah. 2 times 12. So this is 2. All right, folks. 2 times 3 is 6. Add these two to get 5. 2 times 5 is 10. Add these two to get the 12. 2 times 12 is 24. Add those two to get 21. This tells us that when we've done this division, we divided a cubic by a first degree polynomial. This is 3x squared plus 5x plus 12. All right, and Miss Lindgren is in the math office. All right, hang on. Thank you. All right, folks, let's stop talking. This tells us that this division, guys, be quiet, that when I do this division, I get 3x squared plus 5x plus 12 plus 21 over x minus 2. All right, let's look at another one. Let's set up another synthetic division. Let's say we want to divide 8 plus 6x plus 5x to the third divided by x plus 2. Now when I set up my synthetic division or when I set up my long division, I want to put it in the order of decreasing powers of x. So I'm not going to leave it in this order. I'm going to put a 5 here, but I need a placeholder for the x squared. There are 0 x squareds. And then I have a 6x and I have an 8. Yeah.
Can it either be x minus 2 or x plus 2?
Yes, so this I'm thinking of as x minus negative 2. X plus 2 is the same as x minus negative 2. So for this division is minus 2.
What'd you say?
I told him to keep it down. When it's noisier outside here than it is in this class, that's a thing. All right. All right. Now we're going to do this division. We need to put a placeholder in when we do synthetic division or long division if they're missing powers of x. All right, so bring the 5 down, multiply, add, multiply, add, multiply, and add. This one's my remainder. So this tells me that this division is, I've divided a third degree polynomial by a first degree polynomial. So I get 5x squared minus 10x plus 26 minus 44 over x plus 2. So we can do our synthetic division only when we're dividing something that looks like x minus a number. And when we do our synthetic division, it's multiplication and addition. So it's a pretty nice process. Now, we've talked a little bit about what happens when our remainder is 0. So we're going to expand on that a little bit. And we're also going to expand on what this remainder tells us if it's not 0. So the remainder theorem. The remainder theorem tells us that if a polynomial f of x is divided by x minus k, where k is a number. The remainder theorem tells us that the remainder equals f of k. So if I plug k into the function and calculate, what I get out is the remainder. So let's go back to these divisions that we've already done, and I'm going to write what this tells us. For this problem, this tells us that f of negative 2 is negative 44. If I plug negative 2 in here and calculate it, I would get negative 44. This tells us that f of 2 is 21. If I plugged in 2 into this polynomial and calculated, I would get 21. The remainder theorem tells us for this polynomial that f of 2 is 27. For this polynomial, f of 3 is 4. So the remainder theorem gives us a way to evaluate functions by doing synthetic division. Synthetic division is pretty easy. You're just multiplying and adding. You don't have to raise things to powers. Anything else other than multiplying and adding. So that's what the remainder theorem tells us. If the remainder equals 0, what does the remainder theorem tell us? F of k equals 0. That tells us that k is a 0 of f of x. That tells us that x minus k is a factor of f of x. That tells us that the point k comma 0 is an x-intercept. All those equivalent conditions that we talked about yesterday. So our goal in chapter 2, this is really the heart of chapter 2. What we're going to be doing is doing division and looking for a 0 remainder, because that tells us that we have a 0 of our function. That tells us a factor of our function. So that's going to give us our zeros. That's going to be how we factor polynomials. So what we're going to do is say we start with a 6th-degree polynomial. We're going to do synthetic division, try to find a 0. That's going to reduce it to a 5th-degree polynomial. We do synthetic division again, reduce it to a 4th-degree polynomial. We keep going until we get a quadratic polynomial and a bunch of factors. For a quadratic polynomial, we can either factor or, what always works on a quadratic formula. So we can always then, when we reduce it to a quadratic polynomial, find the remaining factors. So that's going to allow us to factor completely our polynomial. So we're looking for our division, we're looking for a 0 remainder. And next time we're going to talk about different ways that we can figure out what would be a good number to try division by to find the 0 remainder. All right, questions? All right, I have one question for you. So knowing what we know, how would we show that x minus 1 is a factor of x to the fourth minus 1? So that's our question. We want to show that x minus 1 is a factor of x to the fourth minus 1. What's a really easy way?
Input 1 into the x.
Put 1 into our function. F of 1, this is x minus 1. F of 1 equals 0. That shows us that this is x minus 1 is a factor because 1 is a 0. That's all we have to do. What's another way we could do it? Synthetic division. Well, let's set up our synthetic division. We're going to divide 1 into, we have a 1x to the fourth, 0x to the third, 0x squared, 0x minus 1. Bring that down. Well, this is easy, right? We got a 1, 1, 1, 1, 1, 1, 1, 0. Our remainder is 0. That tells us that x minus 1 is a factor. But that also tells us that x to the fourth minus 1 is x minus 1 times x to the third plus x squared plus x plus 1. So we've gone one step into factoring x to the fourth minus 1. So, I don't know if you remember in Algebra 2, some students learn Algebra 2, factoring sums and differences of cubes. So, for example, x cubed minus 8. And there's a way that you can remember how to factor it. A lot of students learn SOAP. For as long as I've worked here, Miss Sharrow's tried to teach me SOAP. That kind of acronym thing doesn't work for me because when I think SOAP, SOAP tells you how the signs go sometimes, or not sometimes, same, opposite, always, positive, something like that. Well, when I think of it, I think sometimes, always. I don't know why. That's just what for years I've tried to do it. But for this polynomial, what would be a 0 of this polynomial? 2.
But that's it.
How about doing synthetic division by 2? So this tells me that x to the third minus 8 equals x minus 2 times x squared plus 2x plus 4. And there I factored my difference of cubes. I've never remembered that method of factoring sums and differences of cubes. I always do the synthetic division.
So much easier.
I think it is. Synthetic division is really easy.
Well, yeah, but it's easier than SOAP. Because I had Miss Cheryl last year.
Yeah, so, yeah. She said, why do you think always, sometimes always? Like, I don't know. They're opposites. All right. Questions? Homework.